In this video, what I'd like to do is to show you that this bound function decreases every iteration. So I need to show that if the invariant and the guard hold, then the weakest precondition of a copy of the bound function followed by the assignment in the loop leaves us in a state where the copy is larger than the original bound function. So by instantiating for the command in the loop and for the bound function, we find that the invariant in the guard implies the weakest precondition of a sequential composition of several different commands post-condition, which is t prime is greater than n minus k. So by sequential composition, we know that the weakest precondition of a sequential composition is found by letting the postcondition of the first few commands be the weakest precondition of the last command, t prime being greater than n minus k. But that last command is k becomes k plus 1. So the weakest precondition of this is found by doing a textual substitution for k of k plus 1. Now, again, we have a sequential composition. So to find the weakest precondition, the postcondition is going to be the weakest precondition of ck becoming ak plus bk, where its postcondition is the copy is greater than n minus the quantity k plus 1. Well, if we look at this, our postcondition is not a function of ck at all. So this update of ck is a do-nothing. It's almost like a skip. And the weakest precondition of a do-nothing or a skip is the original postcondition. So the weakest precondition of this will be t prime is greater than n minus the quantity k plus 1. Now we need to find the weakest precondition of the copy, where the postcondition is t prime is greater than n minus the quantity k plus 1. So again, it's an assignment, so we do a textual substitution. For t prime, we substitute n minus k. So we have an invariant in a guard implies n minus k is greater than n minus k minus 1. Well, if we think about it, on the right-hand side, n minus k being greater than n minus k minus 1 has to always be true. And any expression implying true by implication simplification is true. And so regardless of what the invariant and the guard are, our situation by defining our bound function to be n minus k, it's always decreasing while we're iterating. And so we have shown that the loop does terminate, and along with showing partial correctness that showed us if it terminated, it ended up in a state satisfying the postcondition, knowing now that it does terminate means that our code segment is correct.